Hello, everyone. Welcome to University Statistics and Probability Made Easier channel, where statistics is taught in a simple and understandable way. I am Emmanuel Danfo, and in this series, I'll be teaching us Stat 111, Introduction to Statistics and what? Probability. The essence of doing this is to help first year students to be able to cope, appreciate, and understand statistics in a better way. So, our teaching has been broken down into models. Under every model, we have what subtopics under them. And since our vision is what promotes understanding, we will be making a what detailed what video. So some of the videos will be taking long. So as a result of that, we will break them down into parts. Some will be only part one, and others will be part one and part two, maybe part three. When we are done with what every model, then we what solve what questions under them. So today we are doing what introduction to what statistics. Introduction to statistics. But before then, let's pray. Our Heavenly Father, thank you for today. Thank you for our lives. As we are about studying, we invite your spirit to help us study. In the mighty name of Jesus, we pray. Amen. Okay, so introduction to what? Statistics. Introduction to statistics. What is statistics? Statistics is the science concerned with what? Collecting, organizing, summarizing, analyzing, and interpreting data and drawing valid conclusions so that informed decisions can be made. That is what statistics is about. So statistics happens to be a science that deals with number one, you first have to collect a data. So you collect. When you collect the data, then you organize the data. So it deals with collecting, organizing. Then when you are done organizing the data, then you summarize the data, you analyze, interpret the data, and draw valid conclusions. When you're able to draw valid conclusions, then informed decisions can be what? Made. So that is what statistics is about. So we are going to deal with what the key words, which is what collecting, organizing, summarizing, analyzing, interpreting, and drawing what valid what conclusions. These are the key words we are going to deal with. When we say what is what collection, collection simply means that you are going to what take a what data. You are going to what gather information. That information you are going to gather, we call it a what data. The act of doing that is the what collection. The act of doing that is the collection. So an example can be that a teacher collects student scores in a test. So this is called what collection. The process of he doing that is called what collection. Then organize. Organize. What's the meaning of organize or organize? It simply means you are making the data orderly and what structured. You are making the data orderly and structured. When you go and collect a data, there may be that they use different approaches in collecting the data. Maybe that when you go there, you observe, and out of it, you get the data. Sometimes you may ask questions. That is called what? Questionnaire. When you ask what? Questions, that one too is another way of collecting the data. All these approaches what you use in collecting the data may make the data what scattered. So you have to what organize it. What is organizing? You are arranging the data in an orderly way so that it will make sense. So that what it will make what sense. And we have what summarizing. Summarizing simply means that you are making sure that the data you are born to collect, you are making it simple. Simple, not complex. Simple. So that is called what summary. You make it simple. You can use what total, using totals, averages, and charts and tables. So you can use what? You can just take the total, the averages. You can use what? Charts and what? Tables to what? Make a what? A summary. Making things what? Simple. Why do you think that summarization is very important? Because when you are able to summarize, then it was saves time. That's why it's very important to what? Summarize. Then we have what we call what? Analyzing what? Data. Analyzing data. Analyzing data simply means that you are trying to make meaning out of the what? Data. You have what? Organized and summarized. You are trying to make meaning out of it. So you study the data carefully to find what patterns or meanings. So you are studying the data carefully. The data you've gone for, you study it carefully to find what patterns or meanings. An example may be that you've gone for a data, checking the what scores of your students against their study hours. So you could see that the student that studied more hours is the one that had what excellent what grades in his or her what exams, and the one that studied less hours had the what lowest grade in his or her exam. So this process we are undergoing, this careful examination you are doing, is called what? Analyzing. You are analyzing. So this is an example of analysis. So it even says noticing that students who study more score what? Higher. Students who study more what? Score higher. Then the last one is drawing what? Conclusion. But before then, I forgot to what? Write the word interpreting data. What is what? Interpretation of data. Interpretation of data simply means that you are trying to what? Explain, explain. So some of the data you have to what? Explain them. That is called what? Interpretation of data. Then drawing what? Conclusions. Drawing conclusions what you have found to make a judgment. Drawing conclusions simply means that what you have found in the data so far needs you to make a what? Judgment. That is simply what drawing conclusion is all about. And what? And the example is that a company decides to what? Increase production because sales are what? High. Sales are high. So the company, out of the data they have collected and out of the sales they are what making, they what? Decide to what? Increase their what? Production so that they make more sales. Where did it came from? By what? First, collecting the data, and in all collecting, organizing, and summarizing the data out of it, then you could see the trend that, oh, it's like today 30 people are buying, tomorrow 40 people, then it keeps on increasing. So as a result of that, the company is making a conclusion or drawing a decision that as a result of the trend the entity is finding from the data, then it is going towards increase what? Production. It's going towards increase production in order to what? Gain more what? Revenue. In order to gain more what? Revenue. Sets of what? Statistics. Statistics has been divided into what? Two ways or what? Two parts. So as a statistician, you cannot decide to be in these two ways, in any of the two ways. You cannot learn to become a what? Theoretical what? Statistician, or an what? Applied what? Statistician. So what are these aspects of what? Statistics? We have what? Theoretical what? Statistics. Theoretical statistics and what? Applied what? Statistics. Theoretical statistics simply means that you are trying to what? Develop what? Formulas. You are trying to develop formulas. You are trying to what? Propound new formulas. You are trying to what? Prove formulas. You are trying to what? Make rules and what? Laws. That is called what? Theoretical statistics. So first you are developing formulas, you are propounding formulas, you are trying to what? Prove what? Statistical theories, formulas, and what? Make what? Rules or what? Laws. That is called what? Theoretical what? Statistics. So this one is saying that it deals with the development, derivation and proof of what statistical theorems, formulas, rules, and what laws. That is what theoretical statistics. And we have what applied statistics. Apply simply means that application of what theoretical or statistics. So what you have learned in theory, bring it into being. Use it to do something. So that is called what applied statistics. Applied statistics simply means what it involves the what application of those theorems, formulas, rules, and laws to solve real world problems. So you have gone to school to go and learn more statistics. When you are done learning this, then you come out and apply it into our real world problems. There are two main types of what statistics. Two main types of statistics. They are what descriptive statistics and what inferential what statistics. Descriptive statistics and inferential statistics. As the name will suggest, for descriptive statistics, describe descriptive statistics. Descriptive means what to describe. They are describing something, and you already know that anything you ought to describe or anything you want to describe already is in what existence. You can see, you know. So with descriptive statistics, you are describing what you have seen. And in describing what you have seen, there are no predictions involved. There are no generalization involved. It's like this. I want to describe this dust. In describing this one, the color of this is black. I'm not predicting. I'm not making generalization. It's what I am seeing. It's what I'm describing. So that is what descriptive was statistics. An example is that let's take it as if you went towards a shop as a statistician. You went to a shop and you took data from the shop owner. And the data you took from the shop owner, you could see the revenue the shop owner makes every day. So Monday, the shop owner makes a revenue of 20 cedis. Tuesday, the shop owner makes a revenue of 30 cedis. When you add their total, you get when you add the total revenue of the shop owner's sales, then it's what 80 Ghana cedis. All these descriptions you are making, all these data you have put pen down and making description that when I added the Monday's revenue to the Tuesday's revenue, I had a total revenue of 30 cedis, which shows the revenue the shop owner made from Monday to Tuesday. This thing you are saying is not a guesswork you are doing, or it's not a generalization you are making, but it's something you are seeing. So with descriptive statistics say that it focuses on what organizing, summarizing, and presenting data that already what exists without making what predictions or what generalization about the what population, about the what population, about the what population, about the population. Then we have inferential statistics. With inferential statistics, it deals with what using data from a portion of the world population to make predictions or generalization about the population. So with inferential, so descriptive statistics is what the person sees, the existing data is what the statistician will use to what will use to draw what conclusions without making no predictions. But with inferential statistics, what the statistician does is that the statistician will what take a portion of what data from the entire population, and the statistician will study that portion of the entire population and use the portion of the studies from that entire population he took from to what make generalization about the whole population. So let's take that as if a teacher sets an exam for his students. And when the examination was due or was done, then the scores, the teacher records the whole scores of the students, and the students were about what 400 in class, 400 in class, and the teacher striking their averages in order to find what the average performance of the whole student. The teacher just took what 30 out of the 500 students. 30 out of the 500 students. And the teacher studies only the 30. So the teacher studies only the 30, strikes the average of only the 30 students, and gets maybe 60%. 60%. So the average score of those 30 students are what 60%. He uses that to describe the entire population and say that the average score of the what students, the entire student that took the test is what 60%. So when this thing is made, then we call it what inferential statistics. That is called what inferential statistics. That is called what inferential statistics. Importance or uses of statistics. This happens to be the next subtopic we are treating, or we are currently to treat. So there are a lot of importance of statistics, but we are going to restrict ourselves to only three of the importance of statistics, only three of them, which is investment, medicine, and governance. Investment, medicine, and governance. So investment, into bracket, money and finance. Money and finance. Statistics helps people invest wisely instead of what? Guessing. Statistics helps what? People to invest wisely instead of what? Guessing. Instead of what? Guessing. In our world, we don't use what? Guessworks in investment. We don't use guessworks in investment. Why? Because let's take that, see, you are having a huge sum of money. You want to what? Invest into a business to gain what? Profit. You just cannot guess that I feel that when I put my money into the business, I'm going to make money out of it. Never. You have to rather what? Lay down statistical structures. You have to what? Get what? Statistical what? Data, analyze them and see if the company is making profit or is accumulating losses, so that you know if you have to what? Invest in or not. So he's saying that statistics helps people invest wisely instead of guessing. We have already talked about it. It shows which investment is profitable or what? Risky. It shows which investment is profitable or risky. So out of the data, you can analyze. Do they normally make what? Do they normally make what? Profit annually? Do their profits normally increases annually, or does they make what? Losses all the time? So statistics will help you know these things. Weigh the balance, weigh it balance, and what? Make sure you what? Enter or venture into any what? Business and make what? Money. So he's saying that it shows which investment is what? Profitable or risky. And the other one is saying that it helps bankers and investors study the market trends. It helps bankers and investors to study the market or trend. So if a statistical data is provided to what? A banker or investor, it helps or enables the banker to know what? Market trend. To know market trend. Is the market booming? Are demands high? The type of company that is coming to collect what? Money from my entity. Are they going to what? Make profit? Are they going to make money for them to pay back my money with what? Interest? Or are they going to make profit and pay me what? Dividend? So it will help the investors, both investors and the bankers to study what? Market trends and know which type of what? Company they should give their what? Money to. They should give their money to. And in medicine, says what? Health and life. Health and life. It is used to test the effectiveness of what new drugs. So in medicine, statistics helps us to what? Test the effectiveness of what new drug. So when a new drug is brought into the system, we don't just stand up and go out and distribute it to patients who are in need or want of it. But we rather test it to see if the medicine that has been discovered really works or not. How do we do that? We go and what? Get what? Patients who are what? Sick or who are in need of that what, particular medicine to cure their what, sickness. So when we go for those people, we try and give it to them and take data out of it. Now, out of the 50 people that we took and give the medicine or the medication to, out of those 50 people, how many were able to survive? So let's take that, see, out of the 50, 40 people were able to survive, 45 people were able to survive. Then it proves or attests that the medicine is what effective. So therefore, we can give it to the world. But let's take it as if out of the 50 people, less than what? 10? Out of the 50, less than 10 were able to survive. Then it means that obviously the medicine is not what effective. So if there are other things to do to improve the medicine, then they what? Do it. That's the importance or relevance of what? Statistics. That's the importance or relevance of statistics. And we have it helps doctors understand diseases and what? Survival rates. It helps doctors understand diseases and what? Survival rates. How? Take a statistical data. Let's take a see what? Cancer. Cancer, to some extent, is not what? Cannot be cured. It's not curable. To some extent, when it at its what? Higher peak, we cannot cure it. We have to what? Manage it. So how did doctors came to discover that? It's through what data that they came to discover data from other what? Hospitals, or even based on what? Their own what? Data they took from what? People who were diagnosed with what? Cancer. Last one is what? Governance. Governance. Government and what? Planning. Government and what? Planning. Governments use statistics to what? Make fair and effective what? Decisions. Government use what? Statistics to make what? Fair and what? Effective what? Decisions. Fair and effective decisions. And what? Population census helps in what? Planning schools and what? Hospitals. Population census helps in what? Planning schools and what? Hospitals. Population census is also a method of what? It's a method or a way we use in what? Taking of statistical what? Data. So population census helps in what? Planning schools and what? Hospitals. Planning schools and hospitals. How does or how do they do that? Population, they are going to take the what? Total of the whole people in the what? The total of the whole people in the country, divide them among what? Parts. Maybe the age populations, the adult population, the working population. So when they are able to divide it into such of stages, they may be able to know if the the younger population or the youthful population are more in the system, then it means that more schools have to be what? Provided, so that the students can be, or the youthful population can be able to get access to what? Education, and help the what? Country what? Become, and help the country to become more stabilized. Or let's take that, see, under the working population, the working population is lesser than the what? Youthful population. So as a result of that, what should the what? Government do? The government can decide to build a lot of what? Industries to help what? Accumulate all these youthful populations into the what? Working population, in order to what? Grow the what? Country or what? Economy. How did they come about it? It was through the help of what? Statistics. So statistics is very, very important. They said take a keynote, take a keynote, take a keynote, or take take note that statistics is not just about what? It's not just about a school subject. Statistics, the word statistics is not just about a school subject or what a university course. But statistics is the invisible force behind investment, medicine, business, governance, and agriculture. Statistics is the invisible force behind medicine, business, government, and what? Agriculture. It helps build a smarter and more successful world. That's the importance of statistics. So statistics is very, very relevant. So it's much important, or it's very important for you to be able to study, understand, and what apply it in order to help build a successful and smarter world. So far, we are on what? Population and what? Sample. Population and what? Sample. Population under statistics refers to the what? Collection of what? The entire of all what individuals. So it refers to the collection of the entire of all what people, or of all individuals, items, or what things of interest for a what statistical what study. So when we talk about population, our main focus is the whole people, the whole people, the entire what people, the entire what items, or what the entire things of what interest in a what statistical what study. That is called what population in statistics. Population in statistics. Whenever you are talking about population, then there is one major thing you have to talk about, which is what? Parameter. Parameter. Parameter is simply the descriptive what value of a what population. You know that in statistics we normally deal in what figures. So the descriptive value of a population is what? Parameter. Parameter, the definition is saying that parameter is a numerical value that describes a characteristic of a what? Population. It describes a characteristic of a what? Population. That is what parameter is. So when they tell you to calculate the parameter of something, or you want to find a parameter, parameter does not have a what fixed or a standard what formula. But whenever a figure is describing the population, then it is what? A parameter. So let's take as if you want to describe a population and use a population variance. The figure you get is called the what? Parameter. Let's take as if you are finding for what? Population mean. Population mean, the symbol is what? Mu. The symbol is mu. So when you are finding for it, the figure you are going to get is called the what? Parameter. If you have to find the what? Population what? Standard deviation, the figure you are going to get after using the formula, that figure is called your what? Population, or it's called your what? Parameter. It's called your what? Parameter. So that's parameter. And we have what we call a sample. A sample is said that a sample is a portion of the what? Entire population selected to represent the population for a statistical what? Study. For a statistical study. Like I already said, most at times it's very what? Difficult to get the entire population to study. So sometimes what statisticians does is that they take a portion from the what? Entire population, and they make statistical study about it. That portion you have taken from the entire population is called the what? Sample. So the population is the entire individual or items or things of interest that you are collected. But when we are talking about sample deals with the what? Portion of the what? Entire population, portion of it. So to a portion of it to make a what? Statistical what? Study. Under the sample we have a statistic. Statistic. Statistic simply is the descriptive value of a what? Sample. A descriptive value of a sample. He said that a statistic is a numerical value that describes a what? Sample. A numerical value that describes a what? Sample. It's just the same. Examples are what? Sample mean. So the sample does not have a what? A standard formula. Just like the parameter, they don't have what? Standard formulas. They are just descriptive values. They are describing either the parameter is describing the population, the sample is the statistic is describing the sample. So that descriptive value. So when you are finding for a sample mean after writing down the formula, bringing in the figures, the answer you are going to get for your what sample mean becomes the what statistic. The answer you get for your sample standard deviation becomes the what statistic. So if you are told to find the statistic, you have to solve for it. So they can tell you to use what sample mean, they can tell you to use any of them, or you have to identify which one to use. And the figure you are going to get out of the what calculations you make will be called either the statistic or the what parameter or the parameter or the parameter. The last one is your sampling error. Sampling what? Error. Sampling what? Error. One of the most important things, sampling what? Error. Whenever there is a sample, there will be an error, a natural error. Okay. Why are we saying a natural error? Okay. A natural error okay because the sample you are taking does not reflect the true what? Population. It does not reflect the true population. So as a result of that, it causes what? Discrepancies. It causes an what? Error. A sample what? Error. So a sampling error simply is the difference between observed what? Is the difference between observed value or what? Sample statistic. So another name for what? Sample statistic can be what? Observed what? Value. And what? The true value. Another name for true value is what? Population what? Factor. So their differences is called the what? Sampling error. Let me give you an example. You take the height of an entire class. Pay attention. So you let me make an example. For example, you take the height of the entire class and you find their average to be 165 centimeters. That's the average of the what? Entire class. So that one will be what? The parameter. That will be the what? Parameter. But when you take the what? Let the entire population, instead of taking the entire what average of the whole population, you rather took a portion of the entire population. So if the entire population in the class, there are 500 students in the class, and out of the 500, you take a portion of it, say 100 students. You took 100 students and you found the what height of those 100 students, the average height of those 100 students to be what? 168, 168 centimeters. Then you use that 168 centimeters to describe the entire class, that the average height of the entire class is 168. Then there will be a what? Sampling error. That sampling error is the difference between the true height, the true average height, which is the what? Population parameter, which happens to be the what? 165. So you are going to take the sample statistic and you take the what? True height and you what? Minus it. So the sample statistics is what? 100, the average is 168 minus the population parameter, which happens to be the true height, which is what? 165. When you find the difference, you are going to get a difference of what? 3 centimeters. 3 centimeters. So that one becomes your what? Sampling error. Sampling error. So the sampling error is the difference between sample statistics and what? Population parameter. Sample statistics and what? Population parameter. We are now on what? Solving. Solving. So solving, it is a data collection method which involves the general process of asking, observing, and what? Measuring data. That's what solving is. Let me take that again. Survey is a data collection method which involves the general process of action. You ask, you observe, and you measure what? Data. You measure what? Data. You measure data. You want to go and collect a particular data. You have to ask questions. You have to be observant. You have to what? Measure. You have to what? Measure. In carpentry work, or okay, in carpentry work, you could see that if a carpenter wants to what? Create a table, they first have to what? Measure, take measurements, take measurements of what? The size of the wood and every the length of the wood in order to what? Make the what? Table. All these things involve what? Statistics. All these things, the interest, she also has to make what? Measurements. She also what? Has to make what? Measurements. All these things involve what? Statistics. The builders, they all what? Use what? So you are taking what? Data. You are taking what? Data. In what? Using observations and asking questions during periods where the government wants us to what? Or wants us to make a census. The government wants us to take a what? A census in order to know the population of every people in the country. They have to what? Use what? Data, statistical data. That is the what? Survey. They have to use all these things. They'll come to you door by door. They'll ask, how many are you in the room? All these things they want. As all these things are statistical data. When it comes to the health profession, in the health profession, they also what? Take what? Data through what? Questionnaires, sometimes through what? Observation. They taking your blood and those things. All these things are what? Part. So these are what? Survey. So it's saying that the survey, it is the data collection method which involves the general process of asking, observing, and what? Measuring data. We have two types of what? Survey. Two types of what? Survey. Which is the what? Sample survey and the what? Census. You should put it at the back of your mind that we are dealing with what? Statistics. So under every course and its what? Terminologies. So when it comes to statistics, the terminologies used in statistics have their own meaning. So population in statistics is different from the normal population we already know. Census in statistics is different from the normal census we already know. So you have to take note of what? That, and take note of the definitions I am giving out. So types of statistics, we have a sample survey and a census. Sample survey, it is a survey which includes only a portion of the population. Sample survey is a survey which includes the portion of the population. So when you are making a survey and you take only a portion of the population, we classify it as a sample survey. As a sample survey. Don't confuse yourself with sample and sample survey. We told you that sample survey, it is a collection of data. It is a data collection method. This one is a method. It's a method. But if you talk about sample, a sample is the portion of an entire population, the portion of an entire population. But a sample survey or a survey, it is a method of what? Collecting data. So the method of collecting that particular data is called a sample survey. So a sample will tell you that 550 students out of 1,000 students. So you see, it is to give you a figure, a sample. By the sample survey, it is talking about the method. The method, what are the methods? Asking, observing, measuring. So that's the difference That's the difference. And it also applies to the what? Census. It also what applies to the what? Census and the what? Population. Census and the what? Population. So I take note of it. So let's move on to what? Census. Census is the method used to collect data from the entire population. A method you use to collect data from the what? Entire what? Population. From the what? Entire population. A method you use to collect data from the entire population. So population will tell you that the total number of people. What's the total number of people in the community? 1,000 people are in the community. It's a figure. 1,000 people. But a census, it is the method. Which method are we talking about? Asking questions, observing, measuring, and others. So the method used to what? Collect data from the what? Entire population. It is called the what? Census. And a survey is a method used to collect data from a portion of the what? Entire what? Population. A portion of the what? Entire population. So we are going to treat what? Differences between sample and what? Population. Differences between sample and population. We are going to use their features to what? Find their what? Differences. So features, the features are what? Accuracy, cost, time, feasibility, and what? Errors. Those are the features. We are going to use those features to find for what? Their what? Differences. Their differences. So the first difference is accuracy. Under population, the accuracy is very high. But under sample, it is what? Less accurate. It is less accurate. Why? Because with population, it is going to give you the true value. It is going to give you the what? True value. True value. But with sample, it is giving you an estimation. It's giving you an estimation. It's not a true value, but so the estimation. So as a result of that, it becomes less accurate. But since the population gives you the entire population, it gives you the what? Entire people, and when it gives you the entire people, and you are making a mathematical you are using it to find the average of something or any other thing. It is going to be what? Accurate. But with sample, it will be less what? Accurate. And another feature is the cost. We are saying that population is expensive, but sample is cheaper. Taking the population is very expensive. Taking the population to what? Make a statistical study is very what? Expensive. Let's take it as if a company wants to what? Know the number of people that when it develops a new product or brings a new product into the what? Country they are going to buy. Then every company has to what? Ask people the value, how important that new product is to them. So if they are able to know how valuable or how important the product is, then the company will be motivated to what? Produce it, because the company knows that when it is being produced, it is going to solve a problem. And when a problem is solved, then they can generate revenue out of it. They can make profit out of it. Do you understand? So, as a result of that, the company has to what? Make what? Statistical what? Study, collect data, and study, analyze it. And in using population, the population means that you are going to take the entire, you are going to take the whole country, the entire population of the whole country, and ask everyone if the new product will be relevant. It's very expensive, door to door. Look at how big Ghana is. Accra, Kumasi, Takrade, all these countries, the company has to go there. So it becomes very demanding and what expensive to do that, because when you are doing that means that you have to hire people, and when you have hired someone you have to pay the person. The person cannot walk and go there. The person has to use what? Transport. You have to cater for all these things. If they were to be two people, they are going to use what? If it's book, they are making the data from, or laptops, they are using it to make their statistical, or if they collect the statistical data, they are going to use two laptops. But since there is the whole country, they have to what? Get more people, use more laptops. So it's very what? Expensive. But with a sample, you take a portion of the whole country. So it's manageable as compared to what? The what? Population. So it becomes so cheaper when you are comparing it to the what? Population. Then we have time. With population, it takes what? Long. It takes long. But with a sample, it's fast. I've already explained it. But I've already explained it. When we talk about time, it is taking long. Taking long, you are taking the population of everyone in the country. It will take long. It can even take you years. Can even take you 2 years, because we are many. But for example, you are just taking a portion of it, a portion of the entire. So it becomes very fast. Relating it to what? Population and feasibility. How feasible the thing is, how realistic it is. That is called feasibility. Is it realistic? That is called what? Feasibility. So it's difficult for larger population. When the population is large, it becomes difficult to use what? Population. So it's very difficult for larger population, but it's very feasible. And as sample, it is very realistic. You can do it. You cannot do it. So it is very feasible. And the last one is what? Error. The last one is what? Error. Says that under population there are no what? Sampling errors. But under sample it is subjected to what? Sampling error. We have already what? Explained it. It is subjected to what? Sampling error. But take note, there is a difference between error and what? Accuracy. Error and accuracy. Accuracy is talking about how close the statistical figure is to the what? Parameter. So you know that the parameter, descriptive value of the population. So that figure you are going to get, let's take it as if it's an average, the true average of the population is 60. But you use the what? A sample. A sample maybe will give you 50. If it's 60, the sample is giving you 100. How close is the sample to the what? Parameter. That is what we are what? Talking when it comes to what? Accuracy. How close is the sample to the what? True population what? Parameter. That is called what? Accuracy. So when it is very close, then we say that it is more accurate. When it is what? When it's far apart, then we say that it is less what? Accurate. It is what? Less what? Accurate. But if you take the population is already the true value. The true value. So it is very what? High. It is very what? Accurate. But with a sample, it is less what? Accurate. So there is a difference between what? Accuracy and error. Error is talking about the difference between what? Sample statistic and population what? Parameter. They are differences. But accuracy is talking about how close the sample statistic is to the what? True what? Or is to the what? Population parameter. Is to the what? Population what? Parameter. Is to the what? Population parameter. So this happens to be the final subtopic under model 1, which is what? Methods of what? Collecting samples from the population. Methods of collecting samples from the what? Population happens to be the what? Final subtopic under part 1 of model 1. The final subtopic under part 1 of what? Model 1. So under the methods of collecting samples, we have 4 basic methods we use to collect what? Samples from the what? Population. 4 basic what? Methods. We have the simple random sampling. We have the systematic what? sampling. We have the word stratified, and the last one is the cluster what sampling. So we are going to delve deeper into what it so that you understand it. So we have simple random sampling. Under the simple random sampling, everyone has equal chance of being what selected. Everyone has equal chance of being what selected. So in simple random sampling, everyone in the population, in the entire population, has equal chance of being what selected. An example is a company has what 1,000 workers and wants to survey what only what 100 of them. A company has 1,000 workers and that company wants to survey only what 100 of them. What does he do? Under simple random sampling, each worker is assigned a number from 1 to 100 and is randomly selected as a result. So out of the 1,000 workers, we are going to assign a count from 1 to 100. So we are going to list them 1, 2, 3, 4 up to 100. Then we continue again. As a result of that, everyone will have an equal chance of being what selected. And we have what the advantages and an advantage or one advantage of what simple random sampling is that it is free from what bias. Bias simply means that you ignore some parts and only will choose what some people. But with simple random sampling, since everyone has equal chance of being selected, as a result of that, it will what it will what be free from what bias. There will be no what bias. One disadvantage is that it can be time consuming and what difficult when the population is what very large or when the population is large. When the population is extremely large, it will be very difficult using what simple random what sampling. It will be very difficult using simple random sampling. And a systematic sample. The second one is systematic sample. With systematic sample, select every end member of the population after choosing a random starting point. So with systematic sampling, what we do is that we select what every what end member of the what population after choosing a random what starting point. After choosing a what random starting point. Read. Let's look at the example. The example says that a school has 200 students and a researcher wants to select 20 students. So the school is having 200 students. The researcher wants to select what? 20 students. Then what will you do? You will then divide the population size by the same what? Size. So you are going to divide the population size by the same size of what the students the researcher wants to what select. So the population size is 200. The students size that the researcher wants to select is what 20. So it will be 200 over 20, which you are going to get what 10. 10. So when you get 10, then you randomly choose a starting number between 1 to what 10. Between 1 and what 10. So when you randomly choose a what um when you randomly choose a number between 1 and 10, suppose the starting number is 4. So randomly you choose what a starting number of 4. Then you select every 10th student starting from the 4th student. Then you move to the what 14th student. Then you move to what 24th. From 24th to what 34th student up to or until you get what 20 students out of 200 students. So this is the what systematic what random what sampling. Now the systematic what random sampling. Says an advantage is that it is simple and easy to what use, especially when dealing with a what larger or with a large what population. So it's very simple when using it, especially when you are dealing with a what large what population. When you are dealing with a what large population. If you study most of times when it comes to what selection when it comes to doing selections and finding what 20 students out of 200, finding people you want to, even in class, in a lecture hall, you want to group you into what groups so that you can do a group presentation. Most of the times you use the word systematic or sample. Systematic or sample. We tell you to count 1 to 4. Then when it ends on the fourth person, then you recount from 1 to 4 again. So it's a way of using what systematic what random what sampling, systematic what random sampling. So you said the advantage of it is that it is simple and easy to use, especially when dealing with a what larger population. When dealing with a larger population, but the disadvantage is that it may produce bias. It may produce biased results if there is a hidden pattern in the what in the population list. So when there is a hidden pattern in the population list, then it is going to what produce what a biased what result. It is going to produce a biased result. For example, instead of moving from the fourth person, 14th person to the 24th person to the what 34th person, you rather move from 14 to 24th to 33rd person. Then you see, then it means that when you do that, then the next one will be a different person because it's a sequence you are following. So as a result of that, you end up choosing the wrong people. Which you shouldn't have chosen. So it will create what biased what results. It can create biased results when there is a what hidden what pattern. When there is a what hidden pattern, it is going to produce a what biased what results. It's going to produce a what biased result. So we are going to move to the what third one, which is what stratify. The third one is stratified. Stratified sampling. Stratified sampling. So let me give you a basic understanding on what stratified sampling. A stratified sampling in stratified sampling is simply what splitting. So you simply what divide or split the population into or split the what the population into subgroups. So the stratified sampling, what you do is that you are going to what split. So you are going to split the population into what subgroups. When you are done splitting or dividing the population into subgroups, then you are going to pick some of the members from each group. So group A and group B. You pick some members from what? Group A. Maybe out of group A, there are 5 members in group A. You pick one. Then group B, there are 10 members. You pick two. So that one is called the word stratified. But the actual definition for stratified is what? Stratified sampling is a sampling method in which the population is divided into distinct subgroups called strata. And a sample is then drawn from what? Each stratum. From each stratum. So you split the population into what? Subgroups. Then when you are done, you pick some of the what members from each what group. That is what it has said here, that a stratified sampling is a sampling method in which the population is divided into distinct groups called strata. And a sample is then drawn from what? Each stratum. Stratum is a what? Singular what? Word. Stratum is what? Singular. And strata is plural. Take note. Stratum is what? Singular. But strata is what? Plural. So stratum, it says that they are what? Homogeneous. So when it comes to what? Within the stratum, they are what? Homogeneous. Within the what? Stratum, they are what? Homogeneous. But among stratus, they are what? Heterogeneous. Within the stratum, They are homogeneous among what? Stratus, they are what? Among the strata. It's not stratus, it's strata. Among the strata, they are what? Heterogeneous. Strata is plural, stratum is what? Singular. So stratum 1, they said what? Grade 9 students. Grade 9 what? Students. So when you pick stratum 1, which is what? Group 1, you pick all grade 9 students. They have common characteristics. What's the common characteristic? All of those students are from what? Grade 9. That's common what? Characteristic. So if there was 150 students in total, all the 150 students in total have common characteristics. And the common characteristic is that they are all in what? Grade 9. Grade 10 students, 200 and what? 120 students. 120 students, they have what? Common characteristics. That they are in what? Grade what? 10. That is what? Stratum 2. So you could see that within the stratum, when you pick grade 9 students, they have common characteristics. They are what? Homogeneous. Homo means what? They have a common what? Characteristic. So they are homogeneous, but they are heterogeneous among strata. They are heterogeneous among what? Strata. So if you pick what? Grade 9 versus what? Or grade 9 and grade 10 students. When you are taking grade 9 and grade 10 students, between them, among them, they are heterogeneous because all students in grade 9 are different from all students in grade 10. So there is no relation among them. So only students in grade 9, grade 10. So you could see that they don't have any characteristic. So they are heterogeneous. They are what? Heterogeneous among what? Strata. So when you pick the stratum simply means that only one grade 9, all grade 9 students. So all of them among that, they are homogeneous. But within the strata, when you pick grade 9 students and grade 10 students, within the strata, they are what? Genius. They are what? Heterogeneous. Strata simply means two or more. Two or more. So two or more groups. Two or more groups. So stratum singular, so one group. Strata plural, two or more groups. So within two or more groups, they are what? Heterogeneous. But within one group, they are what? Homogeneous. An advantage is that it gives what? Better representation of all groups in the population. It gives better representation of all groups in the what? Population. It gives a better representation of all groups in the what? Population. We know that when we are taking grade 9 students, grade 9 students against grade 10 students, and we are taking them, adding them together to form a sample, you know that 5 of them are what? Grade 9. If you take 5 from grade 9, 10 from grade 10, 5 of them are from where? Grade 9. 10 are from what? Grade what? 10. So it's what? Gives a what? Better representation of all groups in the what? Population. In the what? Population. A disadvantage is that it can be what? Difficult and time what? Consuming to divide the population into what? Strata. It is difficult and time consuming to divide the what? It can be difficult and time consuming to divide the population into what? Strata. And he's saying that a researcher, an example is that a researcher may spend a lot of time grouping people according to what? Ages, gender, and what? Income level. So you want to group people according to their age, their gender, their income level. In doing that, it may be difficult. Why? If the population is very large and you are taking a sample from the population using this method, which is the stratified sampling method, is what? Taking the population, taking a portion from the population, using the stratified, it may be difficult when the population is large. When the population is what? Very what? Large. So the last one, which is the fourth one, is cluster sampling. Cluster sampling. Cluster sampling simply involves the method whereby what? whereby we split the population into groups. You first have to do what? Split the population into groups. There is a difference between what? Cluster and stratify. So pay attention. So we are going to split the population into groups. Then you do what? Pick some groups and then use everyone in those groups you have picked. So you split the population into groups, and after you are done splitting the population into groups, you pick some of the groups. When you pick the groups, then you use every member in those groups you have picked. That is called cluster sample. That is called what? Cluster sample. With cluster sample, all members within cluster are usually what? Heterogeneous. They are mixed. They are what? Mixed. They are what? Hetero what? Genius. They are hetero what? Genius. So, for example, you are making a statistical study about schools in Ghana. With cluster, we are telling you that pick schools in Ghana may be they are plenty. So with cluster sampling, what you are going to do is that you are going to select 100 students from the what? Entire schools in Ghana. When you are done selecting the 100 students, then you are going to pick some of you are going to select 100 schools, not students. You select 100 schools in Ghana. Then, when you are done selecting those 100 schools, you are going to pick some of the schools you have selected. Out of those, schools you'll be picking, then let's say out of 100, you pick 70 of those schools. Those schools you have picked, you have to what? Use every member every member in those schools. You have to use every member. That is what cluster sampling is all about. And it is saying that with cluster sampling, all members within the cluster are usually what? Mixed. They are what? Heterogeneous. An example is what? A researcher randomly selects 2 schools out of what? 5 schools to study all of them. So out of the 5 schools he picked, he now picks what? 2 schools out of the 5, and then studies what? All the 2 schools. That is called what? Cluster what? Sampling. So let's see. Say that school A, 200 students. In school A, there are only what? 200 students. But the thing is that there are what? Mixed what? Grades. That makes it what? Heterogeneous. Heterogeneous in the sense that in the school, there are what? Mixed what? Grades in the school. Someone is in grade 9, another one is in kindergarten, the other one is in crèche, the other one is in grade 1. So there are what? Mixed grades. So with heterogeneous, they are what? They are what? With what? With what? With a cluster, they are what? Hetero what? Genius. They are usually what? Hetero what? Genius. They are usually what? Heterogeneous. If you pick school B, 300 schools. So it's what? 300 students. The same thing. Mix what? Grades. Mix grades. And we have what? Advantages of what? Cluster sample. Advantages of cluster sample. One advantage is that it is cheaper and easier to carry out. Very cheap and easy. Very cheap and easy. A researcher, you want to make a statistical study, you cannot study the whole Ghana school system. So as a result of that, you can pick what? Some of the schools in Ghana and make a statistical study about it. When you pick some and you don't pick all, then it is very easy. The amount of money you would have spent picking all schools in Ghana will be lesser than the amount of money you will spend picking some students, some schools in what? Ghana. Some schools in what? Ghana. And it's very what? Easy what? To what? Carry out. Very what? Easy to what? Carry out. The disadvantage is that it may be less accurate because the selected cluster may not fully what? Represent the whole population. You know what accuracy is. Accuracy means that the thing is when it's highly accurate, then it is close. It is close to the what? Population what? Parameter. It is close to the what? Population. But cluster, you are picking some of the schools, not all. So as a result of that, there is no way there will be what? Accuracy. There's no way there will be accuracy because it's some. So there will be what? Less what? Accuracy. There will be less what accurate. So it's saying that it may be less what accurate because the selected clusters may not fully what represent the whole what population. May not fully what represent the whole population. So this brings us to the what part one of what module one under introduction to what statistics. Thank you very much for staying connected with us from the beginning up to the what end, up to the end. It's very important to do that if you really want to what understand the whole topic. As we have already told you that statistics is not all about school what a school course, but it goes beyond the school course. So when we make such videos like this, you have to take time and what watch all of them, understand it, and practice what more. If you think you are tired, you can what pause the video, go and stretch some more, and come back again, and come back again, and come and watch to the end. Thank you very much, and God richly what bless you. So let's pray and close. Our Heavenly Father, we thank you that you have been able to help us come to a successful conclusion to our studies. Oh, we thank you. We appreciate you. In the mighty name of Jesus, we have all prayed. Amen. Bye bye.